And two-step equations involving integers. Pause the video, take a minute to copy down your target and work on your warm-up. And once you have completed your warm-up, I'll put up the answer and we're ready to begin. Pause the video now. So hopefully you've copied down your target at this point and you've completed your warm-up. I found an average depth of negative 31,811.25 feet. Remember average, so you're adding them all up in the numerator and then dividing by how many they are. These four trenches have the total of this depth. Divide by 4 and there's your average. Today we're going to focus on solving equations. Remember that when you solve an equation, your goal is to isolate the variable on one side of the equation by using inverse operations. So go ahead and write that down. Inverse operations. You're going to undo what's already being done. Remember that we have, please excuse my dear Aunt Sally, for simplifying. So that's PEMDAS. This is how we know how to simplify things. So we start with the parentheses and we work our way towards the S for simplifying. Well, now we're solving. Solving means you're starting at the end and you're working backwards. We're trying to get back to the beginning. So when you solve an equation, you're going to start at this side and you're going to work to undo the order of operations. Okay, so you may want to write this down, jot it down, draw it. If you're thinking of solving as undoing what has been done. Okay, that's why we use inverse operations. To undo addition, we would use subtraction. To undo multiplication, we will use division. The other thing, I have a little picture here. I said, whatever you do, what am I saying there? Keep the balance. So whatever you do, keep the balance. When you solve an equation, it's so important that if you do something to one side, you must remember to do it to the other side. All right, so let's start with these three examples here. We're going to solve the equation and we're going to check our answer. Make sure you show your work for that. When we solve an equation, it's so important to keep your work nice and neat and organized. Keep everything lined up and it'll help you do better, okay? Take a look at this first equation. We want to get this x by itself. What's happening to my x? What is on that same side of the equal sign as x? It's a minus 3. We'll think about undoing minus 3. In order to undo that, we would add, minus 13. In order to undo that, we would add 13. What is the point of doing this? Why am I doing this? I want whatever's happening to x to go away. I want this to be canceled. How do I cancel out a negative 13? I add 13. When I add that, I will get a 0, and that's what I'm looking for. I want it to be gone so that I can isolate my x or get it by itself. But whatever you do to one side, you must do to the other. So we must write it on the other side of the equal sign as well. And now I can add everything together here. So I can pull the x down. I didn't change that. Technically, I would have x plus a 0 here. Pull the equal sign down. And then I have negative 6 plus 13. Remember your addition rules. We have different signs here, so we're going to find the difference and keep the sign of the larger one. So we end up with 7. X plus 0, well, do I need that plus 0? Is that changing my x? No. So we can just drop that plus 0 down. And we have x equals 7. There's your solution. Once your variable is by itself, that's how you know you're finished. Show a quick check step for me. How can we check this? You can always check your work by plugging it back in. So plug in the 7 where x was, and let's see if this is equal. We're going to check this. So put a question mark under the equal sign because we're not sure yet. Well, what's 7 minus 13? Subtraction, we would change that if we wanted to adding the opposite or plus and negative. And now we have a negative 6 equals negative 6. Is that a true statement? Does negative 6 really equal negative 6? Yeah. Then we could check down. If you get down to the bottom and you have a number that's not equal, then you know that your solution is wrong. But negative 6 does equal negative 6, so it works. Okay, let's try B and C. B, again, isolate the variable. So I like to circle the variable. I want to get this all by itself. Let's figure out what's happening to it. Well, I see a negative 5 minus the r. I want to get rid of this negative 5. In order to undo that, I would add 5 to both sides. But whatever I do to one side of the equal sign, I must do to the other side of the equal sign. So I have to add 5 over here. Now let's add each column. So I just line everything up. I'll add this column. Negative 5 plus 5 is 0. Do I need to write that down? No, it's canceled. I have this minus sign. Don't forget that. And then I have this r. So you have to keep that minus sign because we didn't get rid of it yet. And then equals, and 5 plus 9 is 14. Now check, is r completely isolated? Is r by itself? This one's tricky because it's a minus r. It's not alone yet. I still have that minus sign that I need to get rid of. But what number could you write in here that would be right next to that r? How many r's do I have? How many r's do you see? 1. So this is not actually just a minus r. It's a minus 1r. Or a negative 1 times r. That's tricky. So make sure you understand that. If you just see x, it's 1x. If you see negative x, it's really a negative 1 times by x. So I still have to get r by itself. I need to get this negative 1 away from r. It's being multiplied, so let's undo that. Undoing multiplication means I would divide by negative 1. Why am I doing that? Because I want to just be left with 1x or 1r. I need to get rid of this negative. Negative 1 divided by negative 1 gives me a positive 1r, and that's what I want. 14 divided by negative 1 is negative 14. You can write the 1r, or you can just write r equals negative 14. Show a check step for me real quick. So check it out here. We have negative 5 minus a negative 14. Put that in for r. And let's see what this equals. We're hoping it's going to equal 9. Well, minus a negative is the same as adding a positive. So we have negative 5 plus 14, which is going to give me a 9. And 9 is equal to 9, so we are good. All right, let's try that third one here. 2z plus 26 equals negative 33. Identify your variable, find out what's happening to it, and undo it. Well, we're adding 26, and we're also multiplying by 2. You have to choose which one to undo first. Remember, you're undoing PEMDAS. So you should always start with the addition and subtraction. Okay, we're undoing it, we're working backwards. So I'm going to undo the addition first. I'm going to subtract 26 from both sides. So I didn't change my 2z. I get a 0 there, that's exactly what I need. Keep my equal sign lined up. And then I'm going to add those two together or subtract, but that's the same as adding a negative. So I have two negatives, that gives me negative 59. Okay, now I still don't have z by itself. It's being multiplied by 2. So I'm going to undo that. I'm going to divide by 2. 2 divided by 2 gives me a 1, or 1z, and that is exactly what I need. So I'm going to have 1z, or just z, equals negative 59 over 2. Or if you want to write the decimal, you can do that as well. What decimal would equal negative 59 over 2? Negative 29 and a half. Make sure you understand that. Show a quick check step for me. So plug it back into the beginning. If I have 2 times negative 59 over 2, and then I add 26. Let's see what that would equal. Well, this 2 is really over 1, so the 2's can cancel. And negative 59 plus 26 is going to give me negative 33, so we are good. All right, pause the video, try these next 3 on your own, and then I'll run through them with you. So pause the video right now and give it a shot. Okay, hopefully you've tried these 3 problems and we're ready to see the answers. On this first one, You would divide by negative 15 to get x by itself, and you end up with x is equal to 40 over negative 15. You can reduce that fraction, so always simplify. You can take a 5 out of both of them, and I end up with x equals negative 8/3. I'm giving you guys problems with fractions and decimals because you're in enrichment. If you're looking up in your class right now, they might have more integers and some smaller numbers to work with. You can handle these. E, looking at this one, we have W being divided and also we're adding. Undo addition and subtraction first. So I need to undo this plus a negative 12. I would subtract the negative 12 to undo that. But minusing a negative, what's that the same as? Minus a negative is the same as adding a positive. It's a little tricky there, okay? So just focus on the operation, keep the number the same, and then remember those rules. So we have W divided by negative 4 equal to, so I'm going to move my equal sign over to keep everything lined up, equal to 23. Then to get W by itself, I'm dividing by negative 4, so I would multiply by negative 4. And I end up with W equals negative 92. On this last one, hopefully you weren't intimidated by these big bad fractions here. I want to get T by itself. Technically, I'm multiplying by 2 and dividing by 3, okay? An easy way to get rid of a fraction is to multiply. I want you to write this in. Multiply by the reciprocal. The reciprocal is a fraction that when you multiply it by the fraction and its reciprocal, you will get a product of 1. So the reciprocal, all it is the fraction flipped over. If I want to get T by itself, I'm going to multiply by the same fraction, but flipped. Negative 2/3, multiply by negative 3/2. Whatever you do to one side, you do on the other. So multiply by the reciprocal when you see a fraction next to your variable. The reason I can do this is because the negative times negative makes a positive. Those cancel. A 3 in the numerator can cancel with a 3 in the denominator, and the 2 in the numerator can cancel with the 2 in the denominator. I got rid of everything by my T. So now I just have T equals, multiplying fractions over here, you multiply straight across. I have a positive 24 over 18. Always reduce it. So what can I take out of both of those? I end up with 4/3. Don't forget, guys, that you should show your check steps on these three. So if you haven't yet, pause the video and add in your check steps. If you need a little more room, you have the margin. Don't forget that space. Okay, we have one last word problem to go over and then a challenge for you to do yourself. With this word problem, you need to set up the equation and then show how to solve it. Jill babysits over the summer before leaving for college. She decides she's going to save 3/4 of all of her babysitting money. That's going to be important. By the end of August, Jill has saved $630 for college. Write and solve an equation to find out how much money Jill earned babysitting over the summer. Choose a variable to stand for what we don't know. So what's something we don't know in this word problem? We don't know how much babysitting money she made. So I'm going to say M is my babysitting money. Now remember, what does the word of mean in math? What operation does that lead you to? Hopefully you're saying multiplication. So I'm going to have 3/4 of her babysitting money, but I don't know what her babysitting money is, so I'm going to put the M in there. That's how she decides to save for college. At the end, what has she saved? She saved $630. So 3/4 of the money she made is equal to the $630. Nice job if you set that up. All right, then how can you solve this equation? We have a fraction times a variable. Remember, what do you do to get rid of that fraction? Multiply by the reciprocal. So we're going to multiply by 4/3 to get m by itself. Whatever you do to one side, you must do to the other. These are going to cancel on the left, leaving you with m. And let's do this multiplication over here. 630 is really over 1. You can multiply straight across and then reduce, or you could reduce in the middle. M is going to come out to $840. Is that what you got? I hope so. Let's do a quick check on your calculator. Find 3/4 of 840. 3/4 of $840. Well, I could reduce this 4 and 4. I can take a 4 out of both of those. That leaves 1. That leaves, excuse me, 210. And then multiply straight across, and I get that 630. All right, guys, that's it for this lesson. You have one challenge here. So draw a picture. It might help you. And then I will post the answer, or you can check in with me during 7th period to get the answer for that challenge. You ready to move on to your next task?